Hello and welcome to video number 18 in the Different Angle 3D video tutorial series for Blender. This is the fourth video in the plasma table project. In the previous three videos we looked at the design principles that we're constraining the project to, and then created the top frame and the angle iron frame below the plasma table. This video we're going to concentrate on the top frame, and we'll look at using Blender's Boolean tool to cut the slots in the top frame so we can then add the slats that make up the surface of the plasma table. Before I cut the slots in the top of the plasma frame, just a quick explanation for anyone that's new and hasn't looked at Blender's Boolean tools. So I'll just quickly show you what the tools do. I've just opened up a default Blender scene with the cube, and what I'll do is just quickly grab the cube, move it to the side slightly, and then Shift A and add a mesh UV sphere. So the two are intersecting. If we just go into top view, I'll just escape, select the cube, grab it and move it slightly so it's just intersecting the corner of the UV sphere, and in side view just grab so that the two objects are intersecting. If you just join them together, and you can do that if I select the sphere and then select the cube and press Ctrl J, they become one mesh. The cube disappears out of the outliner, and now you've only got the one mesh with all of the vertices. If you tab into edit mode and go into wireframe view, you'll see that the cube penetrates the UV sphere, and all the internal vertices within the cube and the UV sphere remain there. So it's not manifold and the two edges aren't joined. If you deselect everything and link select just the cube, you can still move it without affecting the vertices of the sphere. So we don't want that, so what I'm going to do is just Ctrl Z back to get the sphere back, so we've got the two separate objects. And if I go into solid view and then with the cube selected, I'm going to just change the visibility in the viewport. So in the preferences window for the cube and the object properties panel, we'll just go down to viewport display, and where it says display as, change that to wire so we can see what happens between the two. We can now go back into the UV sphere and add a Boolean modifier. So go into the modifiers tab for the UV sphere and then add a Boolean. And in the Boolean modifier, the object that we're going to use as a Boolean object will choose the cube from the drop down, and straight away it's set to difference, and you can see that it's extracted or subtracted the cube from the sphere. So you can see the corner cut away, but this time the sphere has got its shape completely removed, and you can take the cube out of view, and the mesh you'll be left with once you apply the modifier will be a fully manifold mesh with the cutaway into it. The other options you've got are union, which join the two together, and if I tab into Z wireframe so we can see what's happening, it's removed all the internal vertices and joined the cube onto the UV sphere. So again, when you apply the modifier, and to apply it there's a little drop down on the top bar of the modifier which gives you the option to apply it. I'm not going to do that at the moment, but you can see it's a manifold mesh that contains both objects now rather than just the sphere. And again, go back into solid, and if we change to the intersect, we've only got a little bit left in the middle between the two objects. So difference subtracts one Blender object from another, union joins the two together, and intersect leaves what's left between the overlap of the two objects. Hopefully that's easy enough for you to understand, and we'll move on now to the plasma table. Okay, I've opened up the project file where we left off in the third video of the plasma table project, which is video 17 in the different angle 3D tutorial series. And we've got the frame of the plasma table all laid out now, and we only really need to work on this very top box section frame. So in the outliner, anything that's marked up as equal angle we can take out of view by just closing the eye icon in the outliner window, and that leaves us with just the top view and the perimeter bounding box frame that we use to constrain all the sizes of the lengths. So we can get rid of that as well. I've got it in here just as plain, so I'll take that out of view as well. And we've just got the top section to work with now, sitting in the correct space in the 3D world above the plane. But the first thing we need to do is make the Boolean object that we're going to cut from the box section. So I'll start off by just adding a plane, add mesh and plane, Shift A for add, mesh plane, and we'll change its width to 500, 600 wide, so we'll change it to 575, and then go into front side view, numpad 3. You see the plane's lying down flat on the XY plane. We need to turn it around now so it sits on the ZY plane, so we'll rotate it on the Y axis 90 degrees. So again, we press R for rotate, Y for the axis, and 90 to rotate it round. And with magnet snap enabled, we can move this up to sit and snap on the inside face of the side box section. But first of all, I'm just going to subdivide one side, so I'll put a loop cut on the plane, which is Control R for loop. Tab into edit mode, just zoom in a little bit. Control R for a loop cut, enter to accept it, and then press escape, and it leaves the cut on the center line. We can delete the bottom two vertices because they're not needed. X vertices. So the next thing is to select all, and we'll grab the plane on the Z axis, grab Z, and take it up slightly past the bottom of the box section. So if I zoom in, you'll see that the vertices are now sitting inside the box section either end of the top frame. So we can now use the magnet snap to bring them down onto the inner face of the box section. So it's just grab, G for grab, Z for the axis, and bring it down and snap onto that top face. So that gives us a plane we can use to cut a thin strip, but it needs some width to it. And depending on what size steel you intend to use for the slats that run across the box section, I'm looking at probably what they use just on a car because I've got plenty of it, so it's about 1.2 mil. So I'm going to put a 2 mil slot in that, and there's lots of different widths of sort of cutting discs for angle irons, ranging from 1 mil up to about 3 mil. So 2 mil would be the obvious size to give you a bit of clearance on 1.2 millimeters to be able to just slot them into the gap. But there's other ways of cutting those slots if you've got access to a milling machine with a slitting saw, or automatic hacksaw with an industrial blade. They usually cut around 1.5 to 2 mil wide. There's various ways of actually cutting the slots. But we've got the plane which has 0 thickness, so we can add a modifier to the plane to give it some width. I'm going to go into the modifiers panel, and we'll add a solidify modifier, and you can see straight away it's taken the thickness to 10 millimeters, and it's taken it to the left hand side of the plane. I want it to offset either side so the plane sits in the middle, so I'm going to change the offset to 0. If it's on -1 where it was, it goes to the minus side of the face normal. If it's on +1, it goes to the plus side of the face normal, and on 0 it sits either side. It's not easy to see, but you can see on the back corner we've now got a thickness that's sitting either side of that, and I want that thickness set to 2 millimeters. And that gives us the cutting piece that we can use at the moment. So what I'm going to do is move that now in top view. If we go to numpad 7 and move it 400 millimeters, so it leaves 50 millimeters between the box section and the first of the slats. So it's G to grab, X for the axis, and minus 400 to sit it there. So that's the first one in place. And what we can do now is use the array modifier on this object just to give us the number running across the top of the table. So again, in the modifier panel, we'll add a modifier and it will become the array modifier. And we want this, first of all, it's acting on the relative offset, which we don't want. So I'm going to take that off, close the tab down for relative offset, and open the tab for constant offset and initiate constant offset, and you'll see the offset is currently at 100 millimeters on the x-axis. We want to move it on the x-axis, but it's actually been applied on the z-axis, and this is because the plane has been rotated from its original orientation of on the xy plane to being on the xz plane. So what we first need to do before we can see the correct offset of the array is to apply the rotation that we've done to the object. So we'll press Ctrl A for the apply menu, and we'll just click on rotation, and you can see it now goes in the right direction, an orientation for the arraying along the x-axis. So all that's left to do now is increase the count, and really that's probably too big a gap at 100. It's because the distance is automatically in at 100 millimeters. So I'll change that distance to 50 and just again increase the count further until we've filled the frame up to the top. So we've got 17 iterations, and if we go into numpad 7 you'll see they're equally spaced across the top of the frame. So we've got the object that we can cut the box section with. So now if we just tab on the box section, and what I'm going to do is go into Z for wireframe mode, and in the box section I'm going to add a modifier which will be the Boolean modifier that we looked at the beginning of the video. And for the object we'll use the plane 002 it will be called, or plane 001, which is what we've just arrayed across the top. And you can see it's now cut the slots in the top of the box section of the back edge of the plasma table, and we'll just repeat that process on the front edge. So select the box section representing the front of the table, and we'll again add a Boolean modifier, select the or the other way to do it is to use the dropper tool. So click on the eyedropper and just click on the object plane 001, and it'll cut the grooves in place for that. So that at the moment hasn't modified the underlying mesh, and we want this to be permanent. So again, on this one at the front we can apply the modifier, and there's a drop down on the top bar of the modifier. Just click the down arrow for the drop down and click apply, and that makes it now, if we tab into edit mode, you can see all the vertices are in place on this side. And if we just tab back into object mode and select the back one, and then we tab into edit mode, you'll see they're not there because it's currently only the modifier that's creating those cutaways. So tab back into object mode, and then in the modifier panel click the drop down and apply. So both of those have now got the cuts made into the box section. The final thing we need to do is make the slats for the box section. So what we can do is reuse the plane that we arrayed across the top, and if we go into numpad 3 for the front view, and while we're in wire view it's as good as any, just tab into edit mode and select the top 2 vertices that make up the cutting plane, and grab them on the z-axis and bring them down, snapping them to the top of the box section. So it's G for grab, Z for the axis, and snap them onto the top of the box section. And what I'll do now, if I just put on edge length, I'll see a convenient length we can reduce them to give us some clearance. So it's 575, so if I move them 2.5 mm either side, we've got a piece of steel we can cut to 570. So select 2 vertices on the left, grab them on the y-axis, G for grab, Y for the axis, and we're moving it 2.5 millimeters. So just type 2.5 on the numpad, and then select the 2 vertices on the other end, G for grab, Y for the axis, and minus 2.5 millimeters to give us a little bit of clearance compared to the slot that's been cut in. So that gives us the slats, other than the fact that they're currently 2 millimeters thick. So for this we can tab back into edit object mode, and I'll just go Z and solid again. Z and material preview looks a little better because you can see the difference between the object without the material and the material that's on the box section. So in the modifiers panel, we've got the thickness as 2 millimeters. We can change this to 1.2 millimeters. So there's clearance now in, if you go number 7 Z, number 7 to look down on the top, Z for wireframe, and then zoom right in on one of these slots. You'll see the clearance that's been cut around the slat that sits in the top. So that gives us the top frame with the slats in, and if we Alt-A to deselect all, and we can go back into the modifier, into the into the outliner, and just put into view the angle line again, just to see the progress we're making with the frame. So we've now got the slats in the top of this, which finishes this video, and in the next video we'll look at the casters and put in a tray in the bottom of the table. I hope you're finding this beneficial, and if you are, as I say in all the videos, don't forget to subscribe to the channel. If you are finding it useful, help me increase the circulation by spreading the word to other people you might find will have interest in this. Anyone you know that is using Blender and looking for a more mechanical sort of approach to the modelling process. But again, thanks for watching. Don't forget to subscribe, and see you in the next video.